Okay guys, we're going to go ahead and cross off number 90. We did not do that in class. We'll do that next year. Number 91, this is one of your favorite problems from the last test, so this will be an easy one for you. Here we have the position. We're going to need to know what the velocity is. So the velocity is the derivative of the position, so 6 minus 2t. And hopefully clearly we can see that the velocity is positive when 6 minus 2t. Let me do this a little bit better. Here, hold on. So 6 minus 2t is the velocity, and the velocity equals 0 when 6 minus 2t is equal to 0, and that's when 2t is equal to 6. In other words, when t is equal to 3. That's when the velocity is equal to 0. Okay. Well, just before that, if you plug in 1, let's say, you get the velocity from 0 to 3 is positive. So the velocity is positive on the interval from 0 to 3, and the velocity is negative on the interval from 3 to infinity. Okay, so 3 to infinity. And so we can get an idea of, I guess this is a rock being blown up into the air, so it's not going to be to infinity. It's whenever the rock comes down, so that's what that value is going to be. But anyway, from 0 to 3, the rock is on its way up. How high does the rock go? Well, we know that at t equals 3, the rock is at its highest point. Okay, and the velocity we know again is positive on the way up and negative on the way down. So we want to just know this part A here is asking us how high does the rock go? In other words, what is the position of the rock when when t is equal to 3? And so we can get that answer by finding S, the position or the height of the rock at the time t equals 3. 6 times 3 is 18. 18 minus 9 is 9. So 9 feet is how high the rock went. Okay, how fast is the rock moving when it is 5 feet above the ground? Well, if we want to know v, we have to know t. And if we want to know t, we have to know the position, or the time that the position is equal to 5. So we have to first let s equal 5. So s is equal to 5. The position is equal to 5. When? Well, when 5 is equal to the position function, 6t minus t squared. Well, if we add t squared to both sides, I'm not finding a lot of room here. Let me do that work way up here on the top of the screen. And I'm going to just solve this quadratic equation. I'm going to add t squared to both sides. I'm going to subtract 6t from both sides. And I'm still going to have that plus 5. And if I set that equal to 0, then and factor, I get t minus 5 multiplied by t minus 1 is equal to 0. So at the time t equals 1 and at the time t equals 5, the position is equal to 5. So 5 feet above the ground, if we mark this as the 5 foot mark, that's at t equals 1 and also at t equals 5. Well, it makes sense. 1 on the way up, 5 on the way down. But part B is asking us how fast is the rock moving when it's 5 feet above the ground. Well, if we want to know how fast something is going, then, well, we better use the velocity at time 1. Now, we already know what the velocity is. It's 6 minus 2t. 6 minus 2 times 1 is 4. And so the rock is moving at a rate of 4 feet per second when it's 5 feet above the ground. How fast is it moving? On the way up. Okay. What is the acceleration of the rock at any time during its flight after the blast? Well, if we want to know what the acceleration is, we have to know that the acceleration is the derivative of the velocity. And the derivative of the velocity with respect to t is negative 2. So negative 2 is what the acceleration is at any time, and that would be feet per second, or feet per second squared. Hope that clears that up for you guys. Let's see if we can answer number 93 while we're here. Here we have the graph of f of x, what values does f of x appear to be non-differentiable. Non-differentiable, remember differentiability, function is not differentiable at corners, at cusps, at discontinuities, and then also at vertical tangents. Okay, so keep in mind there's 4 places in which f of x is not going to be differentiable. Okay, continuous for these 3, discontinuous here. So anyway, if we take a look at the graph of f, we see we have a sharp point there, we have a discontinuity there, and of course this is a discontinuity here. And what are those x values? Well, those x values are -1, 1, and then also at 3. I don't see any vertical tangents here, so that's it, -1, 1, and 3. Okay, there you go. That's about it, I guess, for this one. See you at the next video.